But at this point in time, the house is pretty much done with the indoor lighting. It's finally here, the last ingredient. Power distribution blocks, power supplies, and I think 500 feet of cable. And then over here on the project table, I got the LEDs that I need. These are the connectors I'm going to go with. Yeah, let's see. We need to say hi to Nova. Grab the ladder, get up there, grab what's up there, undo it because we're redoing it, and we'll go into the makerspace. And here is where we'll do the work with the soldering and all the good stuff we need to get done. And so, time to start on this project. Alright, so this is the plan. We're replacing this power supply with one of those tiny ones I just got on the table. It should be more efficient, and we don't need this outdoor rated power supply inside. This ESP8266 that I'm using as the brain, I found that I didn't really get good connections with the jumper wires. So we're actually going to go ahead and hardwire and solder directly to this. And we're going to replace this little DIY power distribution block with something made for it with higher rated power. Right now there's an LED strip up there, which was an experiment and I liked it. And what we're doing is we're going to take down the Philips Hue lights that are up here still, up there still, and we're going to add new lights over here where there currently are none. That's what the wire is for. The wire is going to be how we carry our data and also carry the power, because when you run that many LEDs, the LED strip itself is not capable of carrying enough power. So we're going to go work on this first and then start putting it together a piece at a time. Alright, let's talk about designing decisions here, architecting it. The first thing is this power supply does not come with a power cable, unfortunately. So I have to find something in the house that I can sacrifice. We've got ground, neutral, and our live line there that we need to get wired up to power this. So we're going to do that first. The other thing, when I was pulling down the old inverter, it was warm to the touch, and you know what that means? It means it's pulling power even when the lights aren't turned on. So I want to get this thing powered up and see how much power it's using when it's just standing by. If it's more than like 10 watts, I'm going to probably put a relay on the main power and then have it shut off when it's not in use, and I'll wire up my automation to turn on the main power relay to power the LEDs. But then that means, do I want it to also power down the brain? Because I was going to power the brain off of this as well using, let's see, I have them in the other room. But I have, oh, they're over here. This is a voltage step down unit, so I can turn this 12 volt power supply into a 5 volt power for the brain. And I was going to use this instead of using a cell phone power supply. So we have to figure out if it's using a lot of power and how we want to control that. And if we turn off the power to this and turn off the power to the brain, that means every time I turn on the lights, I'm going to have to wait about 30 seconds before it wakes up and I can actually change the colors and adjust the lights. So let's find a power cord. Let's do that first. Let's test this out, and then that will determine how we go about hooking the whole thing up as a whole. Alright, this is just a standard PC cable. I have a bunch of these because I'm a computer guy, so that will be our sacrificial cable here. So goodbye, cable. Now it looks like we actually have these color coded, which is nice, but keep in mind polarity is really important. If you're plugging this into the wall, the blade that would be on the left is going to be the neutral. So we're going to tone that out after I strip the cables back, just to make sure we have our polarity correct before we hook it to the power supply. Alright, continuity testing. Let's verify. Now the way this works, the white should be our neutral, but if it's from China especially, don't trust anything, test it. So let's try that out. Yeah, white's neutral. Let's make sure we know what's going on with the other two colors. Green. Green is our ground. So we know that green is ground, white is neutral. Alright, trust but verify. We are hooked up. Especially when working with high voltage, let's always check everything. So this should be our ground right here. And this should be our neutral right here. And of course there's only one left, so I don't really have to test the last one, but so we're good there. Let's go ahead and hook up a power meter and see how much power this thing pulls. And then also we can adjust the voltage output if we need to. So we're going to try to get close to a 12 volt output on this. Alright, so hooked up with no load on it at all right now. And this might change, I'll retest it later once I add some stuff to it. But we're getting 1 watt, which is absolutely awesome. So I'm not going to worry about leaving this running all the time, but we want to make sure our voltage output is good. So let's test one of these outputs here. This is our positive voltage, this is our negative voltage. 12.02, absolutely perfect. So this thing's hooked up and ready to go. We're going to move into the next phase, which is going to be our voltage step down for powering the brain. Alright, next thing is there's an input, there's an output. We went with red and black, red being our positive side. These are pretty small wires and I want to be able to interface them easily without having them get frayed and all jacked up. So I got a little crimping set here and I'm putting these little baby crimps on here. One side will just have a spade bit that's going to be used for where the power comes in. The other side I'm going to use something from another kit because I want to be able to quickly disconnect it. So this part is annoying. We could solder this for extra protection if we really needed to. And you should always test your connections. Make sure they're good to go. So let's test this guy. Good. Good. All right, cool. Let's hook this up to the power supply and get our voltage tuned in. All right, we're hooked up here now. Got that in line with the power supply. Checking two things. One, we need to get down to 5 volts. It's a good thing we checked this. Right now we're almost 12 volts, which is no drop at all, and it would have fried our circuit. The other thing is, now that there's a load on the power supply, I'm curious how much more power it's using instead of just 1 watt. So right now it says we're using still 1 watt. And let's try tuning this down to 5 volts. .08 volts. That'll work for me. Let's get this now plumbed into the brain and we'll see if it powers it like it's supposed to. Alright, back to soldering and crimping. So let's look at our step down module. We got the spade bits, if I'm in focus, I don't know. That's our input side. On the output side, I'm putting male connectors on this side, and then on the ESP8266, we're going to solder some wires on here with female connectors, and that'll give us a way to disconnect this if we ever needed to work on it. So, more fun. It's nice when you buy a nice tool and it doesn't really work that great. It's a nice thing, but let's see. And we should definitely test those as well. Good. Alright, sweet. Let's work on some soldering. Alright, ESP8266 NodeMCU. We're going to be powering it off of the VIN pin, and we're going to be powering, we need data and we need ground. And we're going to use data pin number 4 for our data. So these old header wires can go bye-bye. We're going to be attaching new wires. Alright, this would be moment of truth. I went and grabbed one of my unused LED strips. It is plugged in directly to the power supply for the positive and negative, so we'll get 12 volt power from the power supply. And then the power supply is going into the voltage drop regulator, which is then feeding the NodeMCU. The green wire is coming out of the NodeMCU and just got it attached temporarily with alligator clips, going into the data line for the LEDs. And I've already got this thing programmed because it was in use before, so it should show up on my phone, and I should be able to control these LEDs if everything's going to go right. So let's check it out. If it goes up in smoke, it's going to be on video. Alright, well, I see the blue light on the NodeMCU. I see the LEDs lit up. The LEDs lighting up just means they have power. That doesn't really mean much yet. Let's on the phone, if I can get it to focus, which I can't. That would be Ambient. That would be the top one. So we should be able to control it from here. So let's try making that green. Or red. Or anything in there. Or let's go for an effect. Let's do like that candy cane one I was doing the other day. Candy cane. So that, my friends, looks like a success. That's going to be the heart and soul. I'm going to probably kind of mount this up in like a project box. And then I got to get on top of the plant shelves and start getting this all hooked up. Now there's another part of the project where we have to start cutting and soldering these LED strips and running our power injection wire, and that's the whole next part of this project. Alright, the next order of business, keeping these electronics safe. So, I've got half of a project box. I have no idea where the other half is. The ESP8266, the voltage step down, they're going to go live in here and be attached in such a way that they'll be secure, but not where I can't get them out if I need to work on them. Everything's nice, it's sitting in there, it's secure, and if I ever needed to, I could cover this box. This will be quite sufficient for our needs. And now we just gotta go put it all together. Alright, we're starting to get into the meat and potatoes. I'm in the repo process. This is what we pulled out. So I pulled out 5 Hue play bars and a bunch of extension cords. And there was 3 up there as well. So in total, what, 8 play bars? And I could sell 2 of them to pay for this entire project. So not only are we upgrading the situation, but we're even going to put money in our pocket. So now it's time to climb up there and start wiring things up. And I'm not sure if I can record that very easy by myself, but we'll see. All right, getting prepped up here. The next order of business is power distribution and power injection. So I'm using distribution blocks and wiring them up to the power supply. 2 lines in because I'm going to have 2 lines out. I want to make sure I have more wires coming in than I have coming out, because the LED strip will connect directly to here, and then our down the line wire will also connect to here. You connect the strips end to end, but what happens is after about 5 meters you'll start losing brightness, because the resistance in the actual copper on the LEDs will start making the voltage drop so much that you lose the power you need to power them properly. So since I'm running, I don't know, probably about 20 meters worth, I need at least 4 points of power injection. So I'm using, this is I think 12 gauge wire, and I'm going to be injecting it every 5 meters or so. So this will be home base right here, and we'll wire everything in. And I'm going to actually cut the connectors off of these and put my own wires and stuff on them, because I don't like the snap together connectors. They don't work very good. Alright, so here I am up top of the kitchen. So not on top of the world quite. And got everything kind of plumbed in. So our the power distribution, the power supply, our brains, our power distribution wire, and the very first set of LEDs. And I haven't tested it yet. So it's time to do a sanity check before we do anything further, because if there's something messed up, I better find out now. So let's see. Let's plug this in and see what happens. Alright, LEDs are on. That's good. Means we didn't reverse anything. I see the blue light on our brain, which means it's powered up. We should be working. I see that it's online. Here it is online. Let's see if I can find a decent camera angle. Again, I have no camera guy here right now. And let's try an effect out and see if this is actually working. Let's go to effects, and we're going to look for the rainbow, because it has lots of color in it. Rainbow. Here we go. Hey, that's a good start. Let's see if I can show you what's going on. So I cut the LED strip at the end, because you have one power injection point and then you have the main place where it connects to a controller. I cut them and spliced them together because the gauge of the wire is so small. I wanted both pieces of wire to feed power, and everything is looking really good at this point. So now what we gotta do is flatten it out and put it up against the wall where it belongs, and then when we get to our first junction point down there, that's when we have more work to do. That is going to be when we cut it. We're going to put some of it over there, and then we're going to put some going the other way, and we have to run data wires separately and a couple other challenges, so we're going to get to those next. Alright, so we're moving along. This part's kind of slow moving, but there's where we started with home base, the LED strip going along the wall, and our power injection wire coming with it. And I'm just curving it around and letting it go up here. And then this is where it ends. So we're doing power injection on the end. So here's our wire. And then it's going into distribution blocks. And then we have one going out to go that way to on top of the cabinet. And we have one that's just going down here for now, which is going to end up over there. So that's going to carry our power. We grabbed our data wire coming out of the LEDs, and we're actually going to split that. So the data signal is going to be the same going this way as it is going that way, and we're using a little white hookup wire to bring the data over there. And I still got to run one more to go the other way as well. Now as far as that side over there, it's a short strip, so just one power point is all that's needed. And how I'm hooking it up, since it's the beginning of a brand new LED strip, it will have the clip on it. So I'm just going to take my raw wire and clip it right into the LED strip and then cut it to length. And that'll take care of that side. So that's what I'll come back with next. And then we'll start moving along to the bigger parts over there. All right, let's do a check-in. Start running down. Our first junction point goes around the bend and just spliced in a strip down there. Let's turn it on. And you can see that those are lighting up now. From here you can see they're kind of like not straight, but when you're down below you can't. And these go. So we're working now. What's important, let's do something like a chase so you can actually see that this and this are working together. So the data line is going through and passing that data like it's supposed to. So now go down there, grab that wire, not step on Nova, and then continue. Nova, are you helping? Are you going to give me some cable? No? You're just going to sit there? It's fine. Alright, we're kind of getting to the last leg of the journey. Home base, over here, distribution. One goes over to the cabinets. The other one going across the way and to another distribution point. Now I actually think I probably could have gotten away with cutting this one line of LEDs and then just stringing power from the end, but why go through this much trouble and not keep doing it the way I've been doing it? So running yet one more extra wire for power, and we got this string of LEDs going down this way. And we did something different since we didn't need to have more than one data wire. We just did the connectors, similar to how we did it for the brain. Just a quick disconnect. Everything in this project has been made so that any piece that gets broken can be easily detached and replaced. There's nothing like permanently affixed. So I haven't done the sanity check yet. That's what we need to do next, is see if this is working before we go to the last piece. Alright, here's our sanity check. We still are lit up all the way across and back over there. Now the question is, will it work if we do something like an effect? So let's pull up that chase pattern again. Chasing there, chasing down here, and over there. So data is still good, and you can see that those two rows over there are the same because we're sharing that data line. But so far everything's perfect. So we just gotta do the last little section and then kind of come back, tidy up our wires, make sure all the LEDs are perfectly laid out the way we want them. And then it'll be dark because it's almost dark. And I can turn off the lights and we can really see how the hard work paid off. So I really despise these clip-on connectors for connecting separate segments of the LEDs. The first time I used these on the TV, I ended up throwing every one of those away and rebuilding it and doing it by hand and soldering. But since those LEDs are kind of already cut and up there, soldering up there will be a pain in the butt, and I'm not running power through this. I just want that data because the end of that LED strip up there, we need to grab the data signal off of it to get it around the corner. But we got power in our power injection wire. So I'm just going to use this. I'm going to cut this in half, put one end on the other end, and splice a data line around the corner, and hopefully we don't have any trouble with that. Alright, the last piece of the puzzle. I forgot that I do need the power wires on the end here, so I'm going to try to use the clip. But if it fails me, I'm ripping it off and I'm going to solder it. And this will be right by the front door. So this will be the last piece, and this will carry it through the whole house. So I'm going to go run the ladder back through again, all the way down there, and we'll power it up and see if everything works, and then we do tidying up. What did I tell you about those stupid clip-on things? Light, no light. One of those two connections isn't making a good connection. So back to that. So here's a bonus content for you. If you really, really, really want your LEDs to work right, this is the only way to do it right. You have to solder them and do it yourself. and this will work really well for your connections. Alright, this is like kind of the end of it here. So I took that down, soldered it, fixed it, and did all that stuff over there. Then I hooked it back up and it still didn't work. Sure enough, I had to come over here and fix this side too. Stupid clip-on connectors. So lesson learned, don't use these things. So I actually just got a portable soldering iron on an extension cord and that fixed that issue. Now everything's all jacked up from having to rip it up and solder it. It's time to put everything back in place and see what it looks like. Alright, I am done for the day. It is finished. All the hard work finally get the payoff. So here's the ambient light set up. I'll build my automation and all that stuff tomorrow. So we got above the kitchen cabinets on both sides. A little bit on this archway and over here in the dining room. And then around the corner from the dining room. And let's see, let me put one more effect on real quick, if I can do this with one hand. Right now, underneath the cabinets, I'm running Twinkle. I like that one, it's really nice. So here's what the Twinkle looks like. The camera's not really showing it, but it's actually kind of twinkling. But yeah, finally got it done. I'm probably going to do one more thing. I don't know if I'm doing it tonight or tomorrow, but the power supply I decided to use has a fan, and once in a while the fan kicks in and it's a little bit loud. So I'm probably going to go back to the other power supply just so I don't have any noise. But that's going to be it for this video, and hope everyone enjoyed it.